Okay, welcome back to 2.2, Part B. Pre-Calculus, Chapter 2, Section 2, Part B. We left off at repeated zeros. If k is the largest integer for which x minus a to the k is a factor of f of x, then a is a repeated zero of multiplicity k. Okay, what we just saw, x squared equals 0. X equals 0. Well, this is multiplicity 2. This is two factors. This is x times x equals 0. Right? X times x equals 0. Well, as you see, when we're factoring, we set each factor equal to 0. So x equals 0 and x equals 0. This is, because it's even, the graph of f of x touches but does not cross through the x-axis. If it was odd, it would cross the x-axis. If this was x times x times x, then we'd have another x equals 0, and it would have to go back down the other way. It would cross through it. So any even power of x as a 0, it crosses, or it touches, and every odd power, it crosses the x-axis. Let's see an example. X minus 2 to the third, x plus 1 to the fourth. This is going to touch when x equals 2. It's going to cross when x equals 2, pardon me, because this is a 0 with multiplicity 3. And here's a 0 at x equals negative 1 with multiplicity 4. And so it's not going to cross the axis, it's just going to touch there. Let's take a look. So at 2, multiplicity is 3, it's an odd number, it crosses the x-axis at 2, 0, and at negative 1, multiplicity is 4, which is even, touches the x-axis. Let's see the graph. Okay, you could do this in your calculator if you wanted to. You could see that. Here's a touch, here's a cross. Example, sketch the graph of f of x equals 4x squared minus x to the fourth. Well, first let's factor this. 4x squared minus x to the fourth. X squared factors out, and you get 4 minus x squared. This is the difference between two squares, and you'll remember from Algebra 1 or Algebra 2, or you might not remember. But when you have a squared minus b squared, it equals a plus b times a minus b. Let me do that out here where it's probably got a better chance of being on the camera. A plus b times a minus b. Okay? It's pre-calculus. You're expected to use these things that we taught you in earlier grades. So this is 2 squared. So this would be 2 plus x, 2 minus x. So our zeros, we'd have a 0 at x squared equals 0, x equals 0, multiplicity 2, and then we'd have another 0 at x equals negative 2, and another 0 at x equals positive 2. These are both multiplicity 1. So we write it in standard form. The leading coefficient is negative. The degree is even. So we know that the end behavior, since it's negative, the lead coefficient, we know it's going to open down. It's even, so we know both sides are going to be going towards negative infinity as x gets bigger. And then we use the zeros that we've just found. Same math as I just did. So we have x equals positive and negative 2, and x equals 0, multiplicity 2. So we're able to come over here and locate positive and negative 2 and 0. 0, the graph is going to touch there. So we're going to see it come up here, cross, come down, touch, go back up, go down, and cross. Watch. X-intercepts, crosses through, 0, touches only. See, and we can just sketch these little features of our graph, and now we just connect it all with a smooth curve. Okay, plot additional points. If you wanted to, you could plug in 1 and see where that brought you. And you could plot some additional points and get a really much more accurate graph. They've put in 1.5, negative 1.5. I'm not asking you to do that. In fact, if you can get this far, if you can get that far, these are both called local maximums. This is a local maximum. It's local to this part of the graph. This one is local to that part of the graph. This is a local minimum. It's local to that part of the graph. So this graph has 2 maximums and a minimum value. Okay? That's the end of that show. Hopefully there'll be some questions on this lesson. Let me now just show you a couple of problems from your homework section. Sketch. Determine the right hand and left hand behavior of the graph. Number 13. I'll do 15 actually. It's a little bit more drawn out. 5 minus 7 halves x minus 3x squared. Okay, our lead coefficient is negative 3. If we were to rewrite this in standard form, negative 3x squared minus 7 halves times x plus 5, we'd see it's going to open down. It's a second degree, which is even. And so on our graph, we would be able to do this. We'd be able to say, opens down both sides. Right there. It's a second degree, so it's only going to have one turning point. And we could come in here and we could find the vertex. But see, this is number 15. Number 15 says determine the right and left-hand behavior of the graph of the polynomial. Determine it. Don't graph it on your calculator. Then if you need to do that, you haven't learned this. This is easy. The right and left-hand behavior. Well, as x approaches negative infinity, f of x approaches negative infinity. That's what that means. And as x approaches positive infinity, f of x approaches negative infinity. That's the answer to the question, right there. You don't have to graph these questions. It didn't ask you to. Pay strict attention to the instructions. Let's go into another group of questions. Find all the real zeros. This is up where 27 goes through to 32 there, 42. Let's pick one of those. I will do number 35. Find the real zeros. T squared minus 4t squared. T cubed minus 4t squared. 35 plus 4t. Okay, well, the first thing I'm going to do is I'm going to factor out a t. So t times t squared minus 4t plus 4. Factored out a common factor. And then I'm going to factor this. Two numbers that multiply together to give me 4 and add together to give me negative 4. That's an easy one. Negative 2 and negative 2. So I have t times t minus 2 times t minus 2. And now the zeros are t equals 0, t minus 2 equals 0, so t equals 2, and t minus 2 equals 0, so t equals 2. That's a multiplicity 2. Multiplicity 2. So here, this is going to touch it's going to touch the x-axis, and here it's going to cross the x-axis. Go back to the instructions, find all the real zeros, determine the multiplicity of each. Do I have to graph it? No. I found the zeros and the multiplicity of each. That's all it asked me to do. Let's go to 67. Sketch the graph. If you use your calculator here, you're really cheating yourself out of learning this stuff inside and out. I will do 67. Sketch the graph. X cubed minus 9x. X cubed minus 9x. Well, let's factor it. X times x squared minus 9, which is a difference of two squares. So x plus 3, x minus 3. So I have a 0 at x equals 0, another one at x equals negative 3, another one at x equals positive 3. Yes, I said each one equal to 0. Nothing has changed from the last 400 times that we've done this together. Okay, x equals 0. X plus 3 equals 0, and solve it. X minus 3 equals 0, and then we solve it. And so we have all these. These are multiplicity 1, which means each one of these is a cross. We have a positive coefficient of 1, a positive lead coefficient of 1, and so we know that the end behavior is going to be just like x cubed. Just like x cubed. We know we have a cross at 0, we have a cross at 3, we have a cross again at negative 3, and so we can sketch our graph. Now, if you want more detail here, find your max and your minimum value. I'm really not concerned with that kind of detail today. Eventually, but not today. So there are examples of 3 types of homework problems. There are actually 3 of your homework problems. I have done them for you. Okay, so I would like you to work on problems, odd problems between 13 and 21, odd problems between 27 and 41, odd problems between 67 and 79. It's going to be a 3-day exercise. That's about 15 problems a day. It's reasonable. Thank you for your time, attention, and attendance.